Okay, so I'm giving you Piotr Pawluk and his presentation, Locust, Playwright and Azure.
Hi, hello, good afternoon. It will be about Locust, Playwright and Azure, and it is combination of several modules which we have used in our one of projects. So this is about the presentation. About me, I'm really passionate about performance testing. I'm not very good in Python, I'm not very good in Playwright. About Locust, I have learned a year ago, about Playwright 2 years ago, or vice versa, so this is something new for me. But I would like to share with you our journey, how to use it in, let's say, some robust way. Okay, so some background. We have ahead quite big project which will require big performance testing and which will require a lot of verification. But for now, we have used one small project. So just to try, just to build the solution. So it was built as a really solution. And what was, okay, as I said, I'm passionate with performance testing. So how normally the performance testing process works. So first we have our purpose. So we know what we want to check, why we want this application to be so fast and other way, why we want to do these tests. We need to collect the requirements for performance, or gather the requirements from business analysts, or analyze them. Sometimes people come with request, okay, we need performance testing, so what's your requirements? We don't know, so we need to help them to collect. Now we need some tools to check, to use. And this whole presentation will be rather on the tools, but let's go further through the process. So usually, if we are not checking from single user perspective, usually we need to automate some scripts, and we need, let's say, step-by-step instruction what we should automate. Profiles of usage, so how many users at the same time should be used during 1 hour, during whole day, 10 users, 10,000 users, or so on, and how often they click the application. We need some test environment, which should be similar to production. We need user accounts, some test data to run the test. It is good to monitor the resources of the system at the same time when we run the test to know if we have enough CPU, not enough CPU, where we have the bottlenecks on the hardware, maybe on some other counters which should be extended. Finally, we run the test, and then we analyze the results. So this is generally high-level process of performance testing. Okay, so our application, our simple application, we had 100 concurrent user sessions. So the requirement was this application should work for 1,000 concurrent users. And we have some simple activity. So first, log in with Microsoft Online, so using this Microsoft command, and then repeat some clicking on one link and another link. Click one, click here, click there. Repeat, repeat, repeat. So this was quite simple test for automation, I thought. Okay, and we have built some process and some infrastructure how to deal with this. So starting on the left side, one time we need to build some development and load performance testing automation. So how to execute, how to orchestrate the tests. The tests themselves should be developed. So manually we create the test cases. Then we need to provision cloud environment, network connectivity, and so on. Then we need to develop, Frontex, it is my company, test orchestration engine, so to run them. And all of this we have done one time. In fact, yes, it is 95% reusable. It means we have done a POC here. And with similar way, we plan to do it, let's say, once and for all. And when we have everything, we can run the test. So just enter parameters how, for example, run with 100 users, or one with 2 users, or whatever. Deploy the infrastructure, which is automated. run the performance test, so it is again automated. Publish test report, automated decommissioning test infrastructure. So for example, for this we need 100 servers or 10 servers or whatever. And if the tests are okay, we go and close the performance testing for and report bugs and so on. If it is not okay, if we need to repeat it, do the loop, so we can repeat it many times. Okay. And now, why we don't need to use Jmeter or Gatling or other tools? So first, these tools, Jmeter or Gatling, are testing on HTTP level, HTTPS level, so generally on API level. And here, if we want, for example, log into the application, we can do it. So user tries to log into the application, sends username, password to some authentication system, receives token, then he can reuse this token and run to the application. And it is easy with some tools because you have the data. In our case, we used Microsoft Login. So yes, username, password to authentication system. This system sends us back some tokens and some things in headers. We are not sure what was needed, what not. And additionally, it sends some scripts to generate the token. And then, on the browser side, the token was generated and then sent to application. So yes, we could eventually learn how to create this script and to create this token, but as it was POC, it was difficult. So rather not on HTTP level, maybe on browser level, just use some test automation tool for this. Okay, other problem with testing on API level. So let's imagine we have application with some field, with some submit button. So we click on submit. Then some request is sent to the server. On the server, the request is processed. And response is sent. And then we have rendering on page. And finally, we have our effect. So on HTTP level, we can measure from sending request to the response. We do not measure this time used for action. On browser level, we have end-to-end time, from clicking to the effect on the page. So this is the second reason why we use this. So we decided to use some tools. First, Locust. It is performance testing tool in Python. Some advertisement from Locust page, so you can go to locust.io and read it. So open source performance load testing tool to test regular Python code. So you write test in Python. Locust 10 can be command line using web-based URL, so you can start it automatically from some other tool. And it is indefinitely expandable, so you can run other tools inside the script. So in Gatling, eventually you have some language. In Jmeter, you just have what Jmeter provides. You can write some scripts, but it is limited. Here you have language with full library of plenty things. And some example testing Locust, some import from Locust, import HTTP users, task, create some hello world user, basic class HTTP user. Here you run the tasks, and this test Locust will start this test and run it automatically. So generally it is on HTTP level here. How to install this? Just first you need to install Python. Then when you have a Python pip, install Locust. And it installed the Locust on your machine. Playwright, we already had a lecture before, so even better than I will tell you. This is the tool for test automation. So enables reliable end-to-end users. Again, from advertisement from web page. First few names. So cross-browser, cross-platform, cross-language, can test mobile application. What is important for me, it can be used in Python. And it takes some browsers with it. So some example, very simple test in Playwright. So here I'm using async mode. So from Playwright async API, import async Playwright, define some function. Yes, here you can run the browser, start the new page, go to the page, wait for, you can print the title or whatever, and wait for the browser closed. And async IO run, and run it in asynchronous mode, and finally you have the result. So very, very simple thing. It can be much more complex, and you can do much more when you learn. But this is the basic stuff. To install, pip install PyTest Playwright, and Playwright install to download the browsers. Okay, so how to connect these two tools? So first, and I will focus on a few points which we had to struggle with, and we have some difficulties. Finally, we have done something. So I will share with you. So first, we have limitations in concurrency. Playwright generally is one-threaded, one process language. So you cannot do multi-threading. In Locust, you are using event. This is something to emulate concurrency. In Playwright, we can have async IO. So these are different mechanisms to emulate these multi-users. We have something which is called Locust plugins. So Locust plugins, it is some package we can download. And in theory, this Locust plugins has inside Playwright plugin, which probably works. However, it do not work in our environment, and I will show you later where it stacks. So we can do it in two ways. So first, run the whole activity using the Playwright. So use this Locust just to orchestrate it, run the test in Playwright. Or you can start the activity in Playwright, for example, log in and gather the tokens, and then use HTTP request later on using pure Locust. So what is this with this limitation? So we can emulate many users at the same time. If you use C Python, then you have real threads, but in normal Python, it is not implemented. However, if you have single user which works in this way, first one action, second action, then action, then action, and you run it with multiple users, you can, let's say, put in these holes some other actions from other users. So each color here represents any user. Yeah, and about this problem with Locust and Event. So Event is a coroutine based on Python used to run the tests. Playwright has two modes, synchronous and no parallelism, asynchronous, async IO. And async IO is to write the concurrent code. So with async and await, you can run concurrently some actions with this limited concurrency. Yes, no, not real concurrency, but limited concurrency. And yeah, if you go the Locust plugins, one plugin named Playwright, and on Windows, it stacks on this line. So event spawn loop run forever, it stacks. It doesn't work here. Probably on Linux it works because Linux is using different mechanisms for async IO. So I was tracking down and so on, and finally I gave up. And yeah, selected other option. So first of this option, how to run Locust. So we have orchestrated it with Azure DevOps, with one instance called master and other instances of Locust named worker. So Locust can work as a master and worker, and each of them could be run on a different machine. And yeah, in your master, you generally manage how to start things, monitor, collect the results. On worker, you actually run HTTP scripts, HTTP users. with the protocol very similar to requests. I think it is even basic on Python requests. If we run it with Playwright, we cannot run so many users because, if you run just HTTP request, it is not consuming so many resources. But if you run the real browser takes the memory, takes the CPU, and it is much more slower, so you cannot run as many users on a single machine with Playwright. So how it was done? So first, from Locust, import single user task between and so on. So import Locust libraries. From Playwright, load download some libraries. We need to create our event loop. On start, just run this loop, and I was creating the decorator function. So you see decorator, which modifies this asynchronously created Python, asynchronously run Playwright to the synchronous one, because Locust uses synchronous calls. So it was trick. So generally, in the loop, just run, and until task is not done, sleep. So the whole test activity in Playwright, we have some preparation, so starting the Playwright and the browser. So it is generally copied a little bit from this Locust plugins. And with the action, we defining our action with these two in our class. We are using our sync, we are using this sync decorator, which was defined before, and we are using task decorator, which is from Locust. So basic on these two, we create our activity, which will be repeated several times. So for example, login page with some timeouts, go to the page, do some exception handling in case of exception, stop the action. And you see this start transaction and transaction. It is part of the Locust Playwright. It is not part of the Locust, but then you can collect data. So you mark when you want to start the time, measuring the time, and then you mark when you want to stop the time. And if it is inside this try catch, it is a success. If it is outside, of course, we need to report an error, so it failed. Okay, but we had some problems here. Not many users could be running parallel, so this is first thing. And second, when you run it on master worker, the worker was so busy by this starting Playwright that had problems with communication with the master. So I had to increase some timestamps, some timeouts. So less intervals, but it was easy to just take them from the Locust runner and override them. So inside the script, you just import runners and change the values, and it works. With less frequency, and it is not then it is not failing. The second thing which you can do, we can capture the traffic from HTTP requests. So we starting login with Locust, with Playwright. So we run the script which logins with Playwright. It generates some token. This token is created, and we can steal this and use in HTTP user. So later we can, let's say, run pure request using only this token. So how to do it? I have created some global environment H, which is for headers. So this is dictionary. And I have defined that function which takes the request as a parameter, uses this global variable, and if the request URL is something which I knew, so something which I expected, then I'm getting this request, so getting request headers and update. This request, it is part of Playwright, so it is inside the Playwright. And then in the login to Playwright, not here. Maybe it is here. In login to Playwright, on this, I registered this function. So request process on the request is executed. And then I do some click. And with this click, the Playwright is creating this, is using this token. So I could steal this. And later, in the function which is, I can reuse it. So this is how to define this. And now I need to start at least once login. So I'm using this decorator from Locust. Just when Locust initiates, on Locust init, I'm running this. If it is not initialized, if it is not master runner, so it is to run it only on worker, not in master. So if it is not master runner, so it is worker, then I'm starting this function, Playwright login, this one. Yeah. And then at the beginning of the test, the user is logged in, and I have in this global variable, I have token and in fact every whole headers. So later, if I'm using HTTP user, so normal Locust thing, I'm adding this headers equals H, so then I can reuse these headers. Yes?
Could you repeat once again why this token cannot be get by HTTP user only? It's necessary to engage browser?
Yes, because it was, the question was, the token was, I cannot just take the token from the browser. Yes, because it was generated by the script on the browser. So I didn't have it from the response. Yes, some JavaScript generated it.
What's the problem with the Azure application? So why did you not consider that approach to generate longer term tokens? Like, let's say, 2 hours or 3 hours tokens and use just HTTP request?
But where from could I take it?
Of course, from automated scripts, which you write in Playwright or other tools.
Yes, so I have done it, but just I have done it in one tool, in one script.
Okay.
So it is in this way. And the token here lasted 15 minutes. However, I could even refresh it later with some other HTTP requests. So it was not a problem with refreshing the token. The problem was just to gather it, to take the first one.
We have one question here.
Mm-hmm. Yes.
Hello again. So my question is, because as a second argument for using this combination of tools, you said that you are performing something from the browser, then it sends to the backend, and we are waiting for the effect on the. But as I don't know if you will go later on to it, but here I don't see this.
This is the second approach. So just here, just to show you, this is.
So basically, in this case, you implement Playwright just because you couldn't get the Microsoft login.
Yes.
Using the script.
Yeah, but in this case, this is the longer one. I just created the full script with Playwright. So then I didn't use this HTTP token, but it has some drawbacks. So you can run only few users on one machine, so you need much more power here. And it is not very stable, in fact, because I need to do this workaround, and still it was not very stable.
Okay, so once you will perform the whole user scenario with the Playwright, and for example, you will get at the effect level 2 seconds. And in the next run, you will get 3 seconds. How do you know where this delay comes from?
This is something which we can dig deeper. So right now, I wasn't on this. However, on Playwright, you can catch some statistics for sure. So if you can hook and take the header, probably you can hook and take much more information, or you can, let's say, store some data here from Playwright.
Okay, thank you.
I haven't investigated this, but yeah, it is a good direction. But there is a problem. The timeout may be because we have not enough CPU on the testing machine. So this could be additional problem. Okay, so let's just go, token, select. Yeah, so in this way, it was just one master, one login action, and then many HTTP users. So then I could use less machine to run the test. So more users with this. And I have developed my own, let's say, tool just to run asynchronously Playwright and don't use Locust at all. The problem was that it should be orchestrated by something outside, so to run it separately on each machine. Separately on each machine, it creates a log file with response times, and then it should be collected back. So much more work on this orchestration part, which was done by my colleague. However, yeah, it is third approach which we used. Not very big code, I don't know, 200 lines of code in Python to do this running it in parallel with this checking if we have enough CPU, because if we don't have a CPU, the next step is not starting. Yeah, and some results. So we are going to the end. From Azure DevOps, we just started the pipeline when we put, some low performance testing pipeline, how many concurrent users, how users per machine, how long should the test take time, what type of tests. So we have this normal test, we have dashboard test with and API tests. This is number of to run the test, we need to run it in with how to say it, because it was done by my colleague. To run many instances, everything here was configured in, I forgot the name of the language. YAML, yes, in the YAML. So we define it in the YAML, and in the YAML you cannot iterate, except you provide some values here. So generally it was. Just run the test, it was deployed, the machine deployed, and then after the test, machines were released, and we have the results which were stored in Azure Analytics just to collect the results. Yes, we wanted to run the 1,000 users, and after 2,000 we have not enough space, error started to grow, so we had an error, raised the error. And the problem was that the application had some parameter just to scale switched off. So we changed the parameter, scale it, let it scale more, and then we had this result. So even with the simple test, we have found the defect. Okay, so how it was built. Azure-based cloud infrastructure, on-demand automation with virtual machines creation, limited possibilities, similar to right amount of user on one machine, so we need several machines. User interface consumes significant memory, so because of this we run it always small tests with this. Automation engine to trigger the test, managing infrastructure, correct results. It was built in YAML, in pipelines in Azure. And of course, rich reporting capabilities out of the box from Azure Cloud. Okay, more or less how it looked like. Azure to orchestrate everything, virtual machines, some key vaults to use username and passwords, reports analysis, reports and log, some application under test here, and on each virtual machine we installed Python, Locust, and Playwright, and then our script. Yeah, so here again the example of a test, and we have some error, and we need to run the machine. So generally cost for 25 tests with 11 machines, 100 users per machine, it was 20 euro from Azure costs. So that's it. Any questions?
Any questions? Okay.
Hi, I will start with the cost which was mentioned the last. What cost 20 euros there? Are servers that expensive, or are you using that huge servers? What's the setup of the VM you are using to run the 100 users? And how many of them are you using?
So here in this test we had 11 machines. So one machine for worker, for master, and 10 for worker. All test 25 minutes plus starting the machines, and this was the cost of the machines.
What was the sizing of the machine?
I don't remember. Just one processor, because anyway you need to run the one process, but enough, quite enough of memory.
We have one other question.
I have a question regarding user experience metrics, which can be collected using Playwright or Puppeteer or Lighthouse, for example. Have you tried to gather some metrics for core web vitals like large content full paint or things like that? Or only you use the Playwright to generate the token?
So in this case, it was third-party application, even out of the box, so it was not developed by us. We wanted just to verify it. Okay, so we haven't done this exercise to verify it. However, even with this simple thing, we have found some problems, which could be fixed. And yeah, the application was very heavy, and in fact, it could be, let's say, optimized. But
do we have any more questions?
All this exercise would have been easier if you didn't have to do single sign-on. Did you not disable it or not enable legacy login because it was third party, or for any other reason?
yeah, it was third party, it was Microsoft application. Part of this was even pure Microsoft application, part was developed by some contractors just for our purpose.
Okay. Any more questions? If not, thank you very much for your presentation.
Thank you.